Traditional fitted sheets often fail to stay in place, leading to frequent shifting and bunching, which disrupts sleep and diminishes comfort levels. This issue is exacerbated for individuals with restless sleeping habits or those who share a bed with a partner. Current solutions, such as sheet clips or elastic bands, offer temporary fixes, but are often cumbersome to use and prone to slipping off. There is a clear need for a more reliable and user-friendly alternative to address this persistence. To combat these issues, integrating Velcro straps along the bottom edge of the fitted sheets is introduced. These straps will be positioned to attach securely to corresponding Velcro patches placed on each side of the mattress. The hook and loop fastening mechanism of Velcro ensures a strong yet adjustable grip, effectively preventing the sheet from shifting or coming loose during sleep.
Modern-day embroidery machines are complex, but when operated by experienced people, it is easy and safe. Although the embroidery machines is easy to use for experienced people, there are times when a less experienced person or children have access to the machine, which is where dangerous situations can occur. Embroidery machines can be used on a variety of materials, so the needles on the machine are strong and sharp. The size of the needle and quantity of needles may vary by machine, but each machine's needles are strong enough to go through most soft materials. Often when a print on the machine begins, the print can be left to finish without constant supervision. The person printing, if they are experienced, will check on the print, but for the most part, it can be left unsupervised since the machine will stop the print if the threads break. Most errors cause the machine to stop the print, but that means an error must occur first. This leads to a potential of a child being able to stick their finger underneath the needle, causing the needle to go through their finger. Most machines will stop after the initial puncture, but just one can cause serious damage. Currently, there is no protective component for the needles, so if an object slides underneath the needle in between the material being printed onto, it will cause the object to be impaled as well. By adding a protective plastic screen in front of the needles, the possibility of objects sliding underneath the needle is minimized. The screen does not touch the material being embroidered, so the pattern will not be altered by the material getting caught on the protective screen. The gap between the material being printed on and the protective screen will be minimal because leaving too big of a gap is dangerous by creating the possibility of thinner objects still getting impaled by the needle and getting stuck to the material being printed on. The plastic screen is attached to the machine's sides by using a snap fit, leaving the component's distance to be adjustable for the different material's thickness. Despite the simple design, it will increase the safety of the object significantly.
Traditionally, watering cans rely on basic spouts for water dispersion, often resulting in imprecise watering and water wastage. However, the incorporation of an iris mechanism introduces a new level of efficiency and control to the watering process. At the heart of this upgrade lies the iris mechanism, inspired by the natural functionality of the iris diaphragm found in cameras and optical instruments. This mechanism comprises a series of overlapping blades or petals that can be adjusted to regulate the flow of water with precision. By simply twisting a knob, users can customize the water distribution for the specific needs of each plant. The iris mechanism empowers gardeners to achieve targeted watering, delivering water directly to the root zone of plants while minimizing runoff and overspraying. This level of precision not only conserves water, but promotes optimal plant health and growth, as roots receive the hydration they need without excess moisture saturating the soil surface. The adjustable nature of the iris mechanism offers versatility in watering techniques. Whether watering delicate seedlings with a gentle trickle or drenching plants with a steady stream, users can effortlessly adapt the flow rate to suit the requirements of different plant species and growth stages. This adaptability enhances the efficiency of watering tasks, saving time and effort for gardeners of all skill levels.
Introducing a simple yet ingenious solution to a common problem: water bottle caps with integrated tethers. Traditional plastic water bottle caps are easily misplaced once opened, leading to litter and inconvenience. However, by incorporating a tether at the base of the cap, the issue is effectively addressed. With the addition of a tether, users no longer need to worry about holding onto the cap separately while drinking. Instead, the cap remains securely attached to the water bottle, conveniently dangling from the water bottle when not in use. This innovative design eliminates the risk of misplacing or dropping the cap, ensuring it will always be within reach when needed. Furthermore, the tethered cap serves as a simple yet effective deterrent against littering. In the past, discarded caps would often litter streets, parks, and water bodies, contributing to environmental pollution. With the cap tethered to the bottle, there is no need to remove it completely during consumption, significantly reducing the likelihood of caps being left behind or improperly disposed of. This eco-friendly feature promotes responsible waste management practices and helps mitigate the negative impact of plastic pollution on the environment.
EpiPens play a crucial role in managing severe allergic reactions, yet their cumbersome size presents a significant challenge for individuals needing to carry them at all times. The current design often renders them impractical for fitting into small bags or purses, leading to instances where people may inadvertently leave them behind, putting their health at risk. To address this issue, a proposed solution involves reducing the size of the spring mechanism within the EpiPen, consequently shrinking its overall dimensions and enhancing its portability. This size reduction will enable individuals to conveniently carry their EpiPens with them wherever they go, ensuring they are readily accessible in case of emergencies. Achieving a smaller spring size without compromising its effectiveness necessitates a material upgrade by transitioning to a high-carbon steel known for its strength and durability. The spring can maintain its structural integrity while occupying less space. This material substitution ensures that the EpiPen remains robust and reliable, capable of delivering the necessary dose of epinephrine to counteract several severe allergic reactions swiftly. Furthermore, the compact design, facilitated by the smaller spring size, opens up possibilities for alternative carrying methods beyond traditional bags or purses. EpiPens can now be accommodated in a wider range of storage options, including pockets, belt pouches, or even attached directly to clothing, ensuring that individuals have quick access to their life-saving medication wherever they may be.
Icing bags are a staple tool in the realm of baking, utilized across a spectrum of recipes ranging from the simplest cupcakes to the most intricate pastries like macaroons and eclairs. Despite their presence in the kitchen, icing bags have seen minimal innovation to enhance their user-friendliness. Persistent issues such as lack of reusability, inability to refill mid-process, and occasional icing leakage have plagued bakers for years. To address these shortcomings, a redesign of the icing bag is proposed. By crafting it from a durable yet pliable silicone material, the new bag becomes not only reusable but also dishwasher safe, ensuring longevity without degradation. This marks a significant departure from the traditional disposable bags, aligning with sustainability goals and modern culinary practices. One of the most notable enhancements lies in the closure mechanism at the bag's rear. Instead of relying on knots or twists, a zip-lock seal is introduced. This innovation allows for effortless refilling during decorating sessions, eliminating the need for interruption due to icing depletion. Moreover, it eradicates the issue of icing seepage, offering a secure seal that keeps the contents precisely where they belong, within the confines of the bag. Retaining the triangular shape synonymous with conventional icing bags, the redesigned model ensures consistency and piping precision. This familiar geometry not only facilitates ease of handling, but also upholds the standard of professional quality decorating. Coupled with the enhanced functionality afforded by the silicone construction and ziplock closure, this triangular design represents a harmonious balance of tradition and innovation. Furthermore, the adoption of silicone as the primary material brings additional benefits beyond reusability. Its inherent flexibility allows for effortless manipulation, ensuring a comfortable grip for bakers of all skill levels. The redesign of the icing bag represents a shift in baking utensil innovation by addressing long-standing issues with reusability, refillability, and leakage.
Phone, wallet, keys, check. Wait, where are my AirPods? AirPods have become a very popular accessory to iPhones, so much so that users have integrated them into their daily essentials. With so many things to grab like keys, phone, wallet, maybe even a water bottle, lunch bag, and backpack for most students. Adding another thing to grab would create a hassle of trying to balance 4 to 5 objects in one hand and creating an environment to leave something behind. The popular AirPods don't have a keychain loop, and while the most recent model does have a place for a lanyard, most people don't have $250 to buy AirPods just for the added lanyard. There are other options like luxury straps. However, there's a much simpler and more affordable way of keeping track of this daily necessity. This simple fix features a slip-free silicone band that will connect the AirPod to a keychain or clip. Gone are the days of wondering where you place your AirPods and trying to place them with the sound. With the proposed design, users wouldn't go on the hunt looking for their AirPods and would instead find them right beside their keys. The loop is made of a silicone material which is flexible, durable, and lightweight, so consumers won't have to worry about the added bulk of a strap or lanyard in their pockets. The loop could be easily manufactured using injection or compression molding, ensuring the product stays cheap compared to the other options.
For construction workers, working outside during a hot sunny day means an increased risk of dehydration, heat stroke, or exhaustion. Even with scheduled water breaks, buddy systems to monitor heat stress response, cooling pads, battery-powered cooling system add-ons, and OSHA required first aid training, thousands of construction workers died due to heat-imposed conditions. The heat trapped under construction hats can be upwards of 30 degrees Fahrenheit hotter than the ambient temperature. None of the alternative solutions already offered for construction hats offer a guaranteed long-term runtime application. Cooling pads have to be reactivated every couple of hours with water, and battery-powered AC cooling systems have to be set up for optimal cooling. The batteries change after a couple uses, and not to mention the $80 upfront charge for the leading system. What if these hats could be made with a material that, instead of trapping heat, dissipates it into the surrounding environment as temperatures rise? This described material would have to be appropriate for long-term outside wear and still meet the ANSI standards for protective headgear. Namely, the material would have to be water-resistant and slow-burning, impact-absorbing, and be able to reflect and disperse heat for the life of the hard hat. Fortunately, radiative cooling materials are readily available as they can be cost-effectively manufactured from plant fibers, fairly common and accepted materials such as silicon dioxide and composite materials such as a porous nylon fabric embedded with silver zinc tin oxide nanoparticles using pre-existing processes and technologies. Researchers at Beijing Jiaotong University have characterized a 50% fumed silicon dioxide paper material as expressing high mechanical properties such as tensile and impact strength, as well as having a high solar reflectivity and emissibility, as well as being waterproof and aging resistant. This material's stiffness can be tuned by its thickness. It has an impact strength of 11 megapascals, and when compared to a cotton white hat, a hat made of the fumed silicon dioxide material on average reduced hair temperature by 55 degrees Fahrenheit. The proposed solution will take this paper fabric and line the inside of the traditional construction hat, helping to reduce head and hair temperatures under the hat. The exterior shell of the hat will be a composite made by layering the fabric with the traditional ABS plastic. This redesigned hat will still possess the safety factors of traditional hard hats with the added cooling properties, increasing working comfort and protection under the blazing sun.